Welcome, ladies and gentlemen, and congratulations to making it to the summary portion of my course for graphing linear inequalities. Basically, what I'd like to do is just kind of run through step by step the process for solving linear inequalities, as well as kind of highlight some tips and tricks and review some common mistakes that I see with myself and within my students in my classroom. When we're looking into graphing absolute value, when we're looking into graphing linear inequalities, it's very similar just to graphing linear equations. So I could go on and on about the process of solving linear equations, but basically there's kind of two forms that we're looking into. One, if it's in slope-intercept form or standard form. And if it's in slope-intercept form, we want to identify the slope and the y-intercept, plot the y-intercept, and then use the slope to find the next to find the next point. Then we can go ahead and connect, and we're good. If it's in standard form, we kind of have two options. We can use the intercept method, which means we're going to plug 0 in for x, solve for y, plug 0 in for y, solve for x, and that's going to identify my two x and y intercepts. Then I can just connect those points, and I got a line. If I don't want to use the intercept method, or it kind of gives me fractions for my intercepts, I can always rewrite my standard form into slope-intercept form just by solving for y. Once I've solved it for y, it's now in slope-intercept form, and I can graph using that process. The only other difference with linear inequalities from linear equations is our line, the points on the line can either be a part of our solution or not a part of our solution. And we can determine that, I didn't kind of say this, if it's less than or equal to or greater than or equal to. So if our inequality is less than or equal to greater than or equal to, then our line is going to be solid. That means all the points that are on that line are going to be a part of the solution. If it's less than or greater than, then it's going to be a dash, meaning any point that lies on my boundary line is going to make my inequality false. It's not going to be a solution. And then we just go ahead and choose a test point. So, well, first of all, we look at our inequality, determine if we're going to be graphing a dash or a solid line. Then we choose a test point, a point that is not on the line. That means either a line or a point above or below, preferably 0, 0 always, because that's the easiest mathematically to evaluate for. And then if it's true, that means if it's true below, that means all the points are true below, so you shade. If it was false below, that means all the points above are true, so you would shade above the line. Some common tips and tricks I'd recommend when you guys are graphing, I think the most important thing is just to make sure you identify the slope and the y-intercept. Understand what slope and y-intercept are. If you can take an equation, especially if you have it in slope-intercept form, just identify what is the slope, what is the y-intercept. Understand that the y-intercept is your coordinate point where the graph crosses the y-axis, and understand that the slope is the ratio of the change in y values over the change in x values between any 2 points that lie on the line. So understand we use the y-intercept to plot our point, and we use the slope to find the next point that lies on the line. The other thing is a lot of students are going to get mixed up. They're going to get confused. They're going to have troubles graphing. So use a table. Create a table. Y, less than x, 3x plus 1, whatever. And choose values for x, plug them in, and determine what the values of y are. Now, when you are creating a table, you're not going to want to go back to an inequality. You're going to want to use an equation. But you want to find, when you have the input values x, plug them into the equation, you're going to want to find the values of y. That's going to give you the coordinate points that are going to make up your line via it being dashed or solid. Now, some common mistakes. I could go on and on about graphing mistakes. Students not using slope, students trying to graph slope, not graphing it when it's not actually in slope-intercept form, and so forth. So I really don't even know what to say here. There's just so many mistakes. It's just very important for graphing lines to make sure you know how to graph a linear equation in slope-intercept form as well as in standard form, because there's just a lot of mistakes there. I could just make a whole another video for that. The next one, though, is choosing bad test points. And that is something that is common with this, or at least having trouble with the shading. So we already kind of discussed, we know if the line is positive or negative, or we know if the line is solid or dashed. So therefore, when we're choosing a test point, we don't want to choose a point that lies on the graph. Because if we have a less than or equal to or greater than or equal to, and we pick a point that's on the graph, we already know it's a part of the solution because it's going to make our inequality true. Or if it's less than or equal to, then we know it's not going to be part of the solution because our graphing line will be dashed. So we always want to pick a point that's not on the line, either a point that is above or a point that is below. And again, the best point to choose is 0, 0, because algebraically, it is the easiest to compute if the inequality is true or not. So we plug in 0, 0 as long as the line doesn't go through 0, 0, and then you evaluate. If it makes the inequality true, then all the points If 0, 0 is below the line, that means all the points are going to be true. And if 0, 0 was above the line, that means all those points above the line will be true. And that's where you shade. So there you go, ladies and gentlemen. That is just a quick little summary. I hope you enjoyed the course, and I look forward to seeing you on another one. Thanks.